I have a question while you're pulling that up, Dr. Lulis, related to the maps, but not the cleaning. So whenever, if profit maps, yield maps are a big part of someone's of a publication that someone's trying to make or submit, is it good to always do that, the Veritas, the colorblind, and rather than the red to green?
Yeah, that's a really good question, because I think we've been conditioned to think of profitability in terms of red and green or red and black.
Right.
But I think it's really important to select a color palette. It doesn't have to be the one that our studio said is, safe for colorblind people, but it's important because 13% of the male population has some form of red-green color blindness, so they're not able to distinguish between some shades of red and green. So for example, I would be able to see the extremes of the red and the green, but where you have that blending in the middle, I wouldn't be able to tell which one it belonged to.
Right. And that's where most is. That's where most of it is somewhere in the middle there.
Yeah. So I suggest that you pay attention to that, and people can look at the legend and understand things pretty easily. But for those of you who don't know what Emily's master's thesis work was on, she worked with a faculty member at Mississippi State to look at areas in fields that were low yielding and essentially non-profitable, and find ways that those landowners could put those areas in conservation reserve programs, for example, quail habitat, to increase the revenue from that land. So you reduce you're putting in inputs if you're farming conventionally and you're not getting any return. And this way, you don't put in the inputs and you get a return from government payments, or you could lease that land for hunting later. Is that correct, Emily?
Yes, sir. Thank you.
So what I want to point out to you is that if you're doing work like Emily's, you have to look at yield data. You have to be very careful about how you clean it, because, for example, we have one area in this field that has been cleaned by everybody who's attempted cleaning, is this area right here. And if you really zoom in, I hate when it does this tilt on you. I don't understand how you stop it from doing that. You can actually see that this area was planted. You can see the cotton rows. What it is, it's a small depressional area that stays wet in the spring if we've had a wet spring. And so this different color you see is that it's dominated by weeds instead of cotton. And so the cotton harvester, I don't think, if you look at the speed files for this area, so if we went to ArcGIS and we clipped this area and looked at the data from here, I don't think we would have had a speed reduction through here. But we probably cleaned it because the yields were on the very low end. But I think it would be important, depending on what you're doing, that you understand, you look at the photographs of the field, you understand what's going on, and maintain the yields in this area so that you could make decisions like Emily made in her master's thesis about whether this would be an area that should be taken out of production, right? So the purpose of your research is really important in understanding how you clean things. And granted, this is not a very big area. I don't know, it's not much bigger than an acre, probably. But let's see. The other thing that helps you, Google Earth is a wonderful thing because you can see a lot of issues going on. You can look at these areas here, where the erosion took place, and because of the shading, the shadowing, not the cotton plants, or that you can actually see that these gullies are quite deep. And now you understand why the machine had to slow down approaching them and then accelerate after the gully. And that's why those areas were clean, because the yields, when you're decelerating and accelerating, are artificial. And so those were correctly cleaned. But we also see that we maintained, the yields in these alluvial areas. The reason those yields need to be cleaned is they're unreliable. Here, they're reliably low. Here, the yields are unreliable. But areas like this, where you have very low yields and you've got some erosion, will probably be important areas to keep in, as well. This alluvial delta down here, which we were able to keep in because it has truly low yields. And by walking this field, areas like here, the cotton would be chest high, and here the cotton would be below knee level, right? So it's really good to have this information. And I know I may have mentioned this to you before, but Google Earth also has, if you go to the view pull down menu, it has this historical imagery option. So if you have that, it shows you all the dates for which images are available for this location. So you can click and see different images. And this one is a perfect image to use because it's bare soil. And you could look at these patterns now and look at the yield map that you've just created, and you will see these soil patterns in your yield map. Okay.
Perfect. And also something that, sorry, Dr. Velides, were you
No,
finished?
I'm done.
Okay, sorry, didn't want to cut you off. Something that I wanted to ask everyone to think about is, so let's assume that this was Emily's field, and she still wanted to use yield editor functions like we developed, but her goal was to still include some of those lower yielding areas because they're true. I mean, I can think of at least a few different ways of doing that, but I want to ask you, like, if you were thinking only about what we did, like using the quantiles and using that approach to clean. So just thinking about that approach in itself, how could you accommodate that? In other words, how could you include those lower yielding areas? Just what would you change in the code to include them? Can anyone
Change
think
the
of-
lower quantile or the lower numbers to have, to go into a lower range. I actually had I don't want to get off on tangent, but I had a professor on my committee when I defended, and he was like, don't you think that just cleaning this data in general is biasing your data for areas that should be in conservation? So basically he was saying that, like, my range wasn't fitting for, it was showing more area that should be in conservation than should be in production. Of course, my PI was like, no, the literature, you can always refer back, but yeah, we had that same issue.
Yeah, that's it's definitely a great conversation to have and something just to think about, because as George said, it depends on your application, what you're trying to do. And yeah, definitely for Emily, that would be important, where perhaps for somebody, like for a farmer that's just trying to perhaps manage that area, but not put in conservation, but just manage in a zone approach, perhaps, I don't know, maybe it wouldn't be as important. So yeah, the goal there is really key. Awesome, thank you.
So what is the answer to the question you posed? We didn't really answer that. How would we code this to include that area in the outcome?
Well, actually, Emily answered. It was, I mean, at least the way that I was thinking too was, instead of using, let's say, the 10th quantile to define the lower quantile, you could use maybe the 5th or maybe the 1st, And again, I guess this comes back to the paper doesn't really explain why 10, why not 9, why not 11th, why not 5th, right? So you can play with that boundary, because that will affect then your min y and max y. And then you can either be more conservative or more liberal of how much data you're keeping in.
Is there a way in RStudio where you could draw a perimeter around that area and then just say buffer include this area in the analysis, not excluded?
Yeah, there are some ways. I mean, it would require some more coding, but yeah, that's definitely another option that could be done as well. All right, so let's see here. We compared that. Okay. All right. So for today, you probably, I mean, we just finished talking about assignment number 2. And what I want to tell you is that last night I uploaded a few things to GitHub. You probably don't have that yet because I uploaded pretty late in the night. But I did upload. So I'm going to show you here on my side, you don't have what I have yet, but I uploaded all the clean GeoJSON for the 3 years to GitHub, and also the partial code for today. So what I want to tell you is everyone that was able to send me the answers, I checked, and all the numbers matched with my numbers. And that tells me that we have the same layers, even if they're not named the same, right? It's very unlikely that you follow the same naming scheme that I did, because, I mean, yeah. However, if you had any issues, if you were not able to go through, if you were not able to export, I included these 3 layers on GitHub because we need them to start the interpolation exercise. And my goal here is really that we all can do that. I don't want, the goal is not to restrict, like if you did not complete or not able to complete, you're not going to be able to follow. That's definitely not the goal. The goal is for us to all move together in the same direction. So with that, I want to ask you to go to my GitHub account again. So if you just type github.com/Leo M. Bastos, maybe this will pop up for you already, but it's that 2022 Advanced PA. So you're just basically going to have to download it again as you've been doing already. So go into code, download zip. Once you do that, I'm going to walk you through here, or going to do this with you just so we can make sure that we all have things in the right place. So I just want to, so this is my Advanced PA GitHub page. This is what you would have downloaded by now, or just did now.
You're not
And-
sharing the screen.
Oh, you're not
sharing
seeing,
the screen.
oh.
Is it, or is it my computer?
I
yeah,
don't see
no,
it either.
Okay.
Yeah, I don't think I started actually. Sorry about that. And thanks for pointing out. That's important.
Yeah, you're
Important point to have. Okay, so well, I was just showing earlier, that to go to GitHub and download again. So code and download zip. Once you download yet another copy from my GitHub repository, what you're gonna see is on the for class code folder, you're gonna see this interpolation RMD script. I want you to either move or copy and paste from here to your own project, to your code folder. So again, from the GitHub folder, you go on the for class code folder, copy that 0218 interpolation partial R markdown file and paste that inside of your own project's code folder. This is what the code we're gonna develop today. Okay, so this step everyone should do. Now the next step is if you send me the R markdown file, everyone that sent me match the numbers with mine, so you don't have to do this next step. However, if you were not able to export the clean versions, or you were not able to complete it, you will need to do this next step here with me, which is going to your 2022 Advanced PA GitHub folder under 03 data. I want you, if you should already have the other files, but the ones that are new that I want you to copy and paste are the ones that have the underscore clean. So KB2 EO 2017 clean GeoJSON, 2019 clean, and 2020 clean. So copy those from the GitHub folder, and then go back to your project and paste them inside of your data folder. Okay, if anyone has any issues, please let me know. We have to have this in place for you to be able to move on. Okay, so I haven't asked you to launch your project yet, but I want to do that next. If you already have it launched, perfectly fine. You just want to make sure that right here on the top right, you do see the project name. If it says project none, that's not going to work. You can just close that RStudio window and follow what I'm going to show next. So what I want to show you next is just, so assuming that everybody was able to copy first the code, the partial code from GitHub to your own personal project's code folder. And second, if you did not produce during the assignment, you should have copied and pasted the 3 clean yield GeoJSONs from GitHub to your personal data folder. Again, if that didn't happen, let me know. But if I don't hear anything, I'm going to keep going. So now I just came to my personal projects folder. I see again that rproj icon. If you go ahead and double click on it, it's going to launch that project for you. I already have it launched, so I'm not going to do it myself. But once it launches, you can come here on the Files tab, click on that R button to take you to the root directory of the project. And then you will have to go into code. And I have some more codes here that you don't have yet, but you would pretty much just click on that 0218 interpolation partial and launch that on your RStudio session. And on mine here, I have some extra text, like the intro text that you don't have, but don't worry, that's not gonna matter for what we're gonna do. So you should be seeing something like this. Okay, I just wanna stop here for 5 seconds. Oh, before I stop, let me actually check something else. So if you're able to get to this point, launch the code, come back again on the Files tab, click on the R to go to the root directory of the project, and go inside of the data folder. I have perhaps 1 or 2 things more than what you already have, but you should see inside of your data folder, you should see the clean versions for the 2017, 19, and 20 data sets. If you are not seeing them inside of your data folder, you're not going to be able to follow exactly what I'm going to show. So here's a good stopping point. I'm going to stop for 5 seconds. If anyone has issues, please let me know. This is the time.
Would you please recover the steps of launching the code?
Yeah, so were you able to launch the project?
Yes.
Okay, so with the code, what you would do, so this is where maybe looks something like this, where you see the console only. You will come to the Files tab, click on that R button to take you to the root directory of the project. And then you go inside of the code folder. And if you were able to successfully copy and paste the code from the GitHub folder into your own projects folder, you would be right here. And so if you just click on it, that would launch it on the site.
Okay, I wasn't sure which one you had selected to click. Thank you.
Yeah, absolutely. Anyone need any help? All right, I'm going to take the silent as a no and keep going, but please stop me if you run into issues. Okay, so my objectives for today for you guys to learn are going to be pretty much to first understand what is interpolation and why do we do it, when is that useful and when we don't need to do it. We're going to explore pretty much only one type of interpolation methods, which is the inverse distance weight, IDW. You may have heard of this already. It's the simplest interpolation method. Well, perhaps not the simplest, but it's one of the simplest, most commonly used in agriculture interpolation methods that there is. And you will have perhaps a whole week with another professor just to talk about interpolation. So my goal here is not to be exhaustive on interpolation techniques, but just to expose you to one of them that we're going to use here. So then we're going to apply this technique to our at least initially to one and eventually to all 3 of our yield data sets. And then we're going to extract information from that interpolated map using a grid. And it's going to make more sense, but where we're going with this is basically have interpolated map, extract mean values from a grid, overlaying that interpolated map, and then use that information next to first look at usability over time, and then to use that information with other layers to create zones. So this is the direction we're going. Okay, so if you want to come to the first chunk here, there are 3 packages that maybe in your code are commented off right now like that, that I'm asking you to install them now. So I don't think you have them installed yet. So what I would do is just uncomment them off and then place your cursor in the first one and then do that command return or control return to run one at a time. So you run the first, let it do its magic. It's gonna appear below on your chunk. And again, if you see that downloaded binary packages are in a place, it means it was successfully installed. So just do that one at a time for each one of these 3 packages. And after you do that, feel free to just comment them off again, because as we talked about this already, we only install once, so you don't have to rerun this every time that you just play that chunk. Once you have all of those packages, all those 3 packages installed, you can just go ahead then, if you commented them off, so please go ahead and do that. After install, comment them off, or just delete that if you want that row. And then you can go ahead and play the entire chunk just to load some other packages in, including those ones.
Are we supposed to get a warning?
A warning is okay. It's probably just saying that there are functions from different packages that are named the same. So one package is hiding the other when it comes to that function. So if it's a warning, it's probably fine. If it's error, then that's the problem.
We have an
Okay.
error.
You have an error?
Yeah, the previous one was a warning that a package was not installed, that something that was needed was not available.
What do you want to share your screen?
Yeah, I'll share my screen, but I ran the chunk now, so the warning has disappeared, but I'll share my screen.
You also have? What does yours say?
It says package or namespace load failed for raster.
Raster. Okay,
Yeah, I have the same error.
the same error. Raster. Okay, so there is a package. Oh, yes. Okay, I see why. And actually, let's do this. Was that the error that you got initially, George? Do you
This
remember?
one was a warning, and I didn't. It was several lines worth, and it basically said that there was something missing that was going to be needed.
Okay, so I still see that your package, like, can you go ahead and try to run the install packages gstat again, just so we see what?
I got the warning when I was running this third one, so let me run that.
Okay. Okay, so maybe for now, at least in relation to that, I think we can try to keep going, because maybe it will not throw things off. If it does, then we'll come back and fix it. And yes.
The only thing I see here about the roster is that it uses SP and not SF. That's all the only thing it says for me. It says loading required package is the SP and not the SF that we have already installed. But that's all. It's like a warning. It's not an error.
Okay, I think we should be okay. Yeah, because some of the packages here use, yeah, I guess I don't want to get into that conversation right now because it can take some time just to go through it. But let's do this, at least with those 2 that Yanis and Dr. Valides showed. I think we can try to keep going, because I hope they're not going to give us any trouble. If they do, we'll come back and troubleshoot. In the case, so Victoria had an issue here where it says package raster was not. Let me start sharing mine again. Okay, so she had a warning saying package raster was not installed. And so we can just go ahead and do like install dot packages raster and run that. And if it says this error for you, you can just say no. Maybe that's not gonna work. Let me try again. Let me try to say yes. Updating. Okay, so I think now. Yeah. Yeah, so if you try to install raster and it gives you a warrant of like a pop-up window, we can just say yes. That's gonna restart your R session and then it should install properly. And then I'm just gonna come here, comment off and just rerun my chunk. Okay, I got mine went through. Anyone else seeing any errors? Perhaps with the warnings, we can try to troubleshoot them later. Hope that they're not going to give us too much trouble. If they do, we'll come back to them. Did that work? All right. It's going. Okay.
I think it's working.
Okay, perfect. So, yeah, okay. So it seems like everyone was able to install and load the packages that we have on the chunk here. So next thing is I want to read in our yield clean data set. So to do that, we're going to use the assign function. You can come to this next chunk, use the assign function or assign symbol. We're going to use the read underscore SF function because we are already importing a geospatial data, which is a GeoJSON file. So open and close quotation marks. In my case, I have to get out of the code folder. I'll do that by .. I hit tab. I go into the data folder and I hit tab again. I have a whole bunch of things, but the one I want to bring is what I called at least yield 2017 clean GeoJSON. If you completed this exercise and exported on your side by yourself, this would be a different name. But if you copy and paste it from GitHub, this is what it would be called. So if we complete that and run this chunk, we should see this data set here, which has 27,000 rows. If you're seeing something different, there could be a few reasons, but if you're seeing something different, just please speak up and we can try to see what's going on. Otherwise, I'm assuming everybody was able to import, and we know, so two ways that we know that it was, oh yeah.
Oh, yeah, so I'm having an issue, and I'm sure it's that same file setup that we had an issue with last class. But I can see it over here on my right in my files, but it's not popping up when I tab, and I'm not sure if, I don't know. Do you think that, I can try to move some stuff around if you want to go ahead and go.
So my first guess is it would be probably that. So first to look and see that your project name is up here.
Yes, sir. Yep.
And if you see there that you browse here on the side, if you click on files, if you click on that R button, my guess is that you're not seeing something like this. You're not in this level, like the root directory of your folder is not at this level.
Yeah.
Do you know? So one way to open this folder, whatever it is in your computer, is for me, I have to drag this bar to the side so I can see it. But if you can see this more engine here and you click on that, you can click on show folder in your window. And that's going to take you to where that is.
Okay.
And I don't know how that works in other computers, but in mine, I can actually see the path right below here. So I can really see where it is. So what I would tell, do you want to share your screen? We can.
Yes, sir. Okay, yeah, so this is what popped up, and I know this is not the correct layout that you were showing at the beginning of the class. It's all in here. It's just not. Huh? Is not sharing? Oh, okay, there we go. Yeah, I know it's kind of messy, but it's all in here. So this is my folder. And it was showing over here because I moved it over from your GitHub.
Okay, so I guess in your case, it's just that you don't have that data folder because you're using the GitHub named one.
Okay,
So for now, let's just do this. Go to your read SF again,
okay,
and if you just remove that data from there and you stop at the / and hit tab, let's see what appears. Okay, so do you know, like in that tree there, do you know where your script is?
yes. It's in here. Yeah,
Or yeah, not the script, sorry, where the data is.
there you go.
Um,
There it is. No,
Is
see, I
that,
can see it over here. Oh, no, that's my bad. That's okay. I'll fix it. Go ahead.
okay.
Sorry.
So I also just noticed that the recording is paused because I paused it early on when I just joined and I forgot to continue. So let's see.
The recording, I'm recording on my end.
Oh, okay. Okay, great, perfect. Okay, that's good. That's good. All right, so we have it recorded. That's great. So Emily, do you think you can
I can
figure?
get it. I'm just gonna pull it from GitHub again, and it's just some file management.
Okay, so
Yeah,
I'm
I'm
gonna
good.
keep going slowly. I think
catch up.
I mean, you will be able to catch up. If you don't, let me know.
Okay, thank you.
Okay. So was everyone else able to import this, the Clean 2017? Okay. So if we run that, the two ways that we know that's been imported is first, when you print it and it appears below here, it means it was imported. Also, we see that on our environments. We're not going to go too much over this because we have already talked a lot about the distribution and such. I'm just going to come to the next chunk and quickly run a summary function, just so we see again, double check that our yield values make sense. The mean and max match what we created when we cleaned them. So that's kind of enough for me at this point. Oh, and also, you know, I kind of forgot to point out, but when we print it here on the first chunk, it's already projected CRS in NAD83 UTM zone 16 north. And that the reason why that's the case is because this is a GeoJSON file and that information is already embedded in the file from when we export it. So it's already coming with it. So we don't have to, if you recall again, the first time that we brought in the yield, it was a CSV, we had to transform it to spatial, assign WS84, transform to UTM. We don't have to do that here now. It's already embedded in the file. I just wanted to point that out. Okay, so we're also going to be importing the boundary from this field here, which we use the assignment symbol with type read underscore SF, open and close quotation marks again. Get outside of the code folder by // hit tab, go inside of the data folder, and you should already have this from the previous classes. That's the kb boundary.geojson. So if you just run that and print, it is just like one vector file, shape file that has one polygon. So we only see one data row here. Was everybody able to complete this step? Okay, I take that as a yes. If you were not, please let me know. Otherwise, let's keep going. Okay, so let's come here next to this next chunk. I pretty much left for you the entire code there just to run. And just to walk you through very quickly, I'm just creating a ggplot where I add the yield data. I change the color palette to varieties and I add the boundary. And I save this plot object to this plot output to an object. So I can call this object again in the future. So if you just want to run that chunk, it's going to take a little while, but you will finally be able to see this. Okay, if it's still running on your side, you can just look at mine because I want to make some points here and call your attention to. So, does anyone here, have you ever heard of interpolation? Can anyone tell me, like, why do we use interpolation methods? Any guesses?
When you clean like the yield files and there are holes, like that area that Dr. Bluth was talking about, those pixels don't have values if it's in that raster. And so interpolation will take the values from surrounding pixels or cells, and it'll take an average and give those empty cells a value. So it just makes it like one pretty continuous picture.
That's perfect. Thank you, Emily. And this is exactly it. So interpolation works when, perhaps let's take one step back here, because yield data, even though it still needs to be interpolated, it's very already dense in itself. Let's think about perhaps you do grid sampling, like soil grid sampling, right? You go on a field, you have a grid, you take soil samples on every point of that grid, and then you come back and you see at this plot, you have a whole bunch of points. What about the values in between those points? I mean, you don't really know because you didn't sample, right? So interpolation helps us to fill in those gaps where you don't have observations for. I want to quickly show you here an example of what I mean by that. So this is kind of, it doesn't really matter much the context here, but what I want you to get from here is this project was sampling at these specific points. But what if you want to know what was that variable, which here I think it's elevation, in a place where it was not sampled? You have to interpolate. And then when we interpolate, we create a continuous layer, continuous map that has estimated or observed values all across it. So it doesn't have gaps. So it looks something like that. So coming back to our concept of the yield data. So as Emily said, we do have some gaps here that we want to fill in. And to do that, we have to interpolate. But
yeah, if you don't mind, I have an example. I can share very quickly my screen to show the students a more extreme example of discrete data points that were interpolated, if you don't mind.
Absolutely. No.
Let me do that very quickly. This is related to the project that Sunab will be doing. Okay, so what you see here on the left is what I want you to concentrate on. This is a relatively small field, but each of these points where there are numbers.
Sorry, I don't know if others can.
Oh, okay. I'm sorry. I didn't complete the share. Okay, there we go. I want you to concentrate on this map here. These discrete points are where we collected samples for measuring aflatoxin in a peanut field. And so we had 17 individual points, and we wanted to create a map of aflatoxin concentrations across the whole field. So this is where interpolation really becomes important, because you've got to understand the proper techniques that represent the spatial distribution of the data, right? So this is what we're going to be learning now, and then later when Professor Morari speaks to us. So what we've got with our yield data is something like this, where it's pretty dense anyway. We still need to interpolate because there may be gaps, but it's not as dramatic as having 17 points in the field compared to 15,000 points like you see here. All right, everybody understand the purpose there? Okay, good.
Okay, let me share my screen again. And yeah, that's definitely it. And one of the points that I wanted to make here is with yield data that is this dense, we don't see the clear benefit of interpolation as you would if you had less dense sampling points. But one thing that I also wanted to clarify is, even though this is still a vector file, so it's a shape file using the lingo that has points, right? So it is not a raster yet, and we'll get to that conversation here hopefully today. But yeah, so this is still data points. It's just, it looks kind of continuous as a raster would, just because it's very dense, but it still have gaps, as Emily said, that we need to fill in before we can extract means from a grid, for example. Okay, so very quickly here, we are going to be doing inverse distance weight, IDW. It's a very simple interpolation method. There are multiple interpolation methods out there. If you want to be more more recognizing of your actual spatial dependence between points and take that into account, you would do kriging. So IDW and kriging are probably the two most common ones. And kriging itself stems into multiple different types of kriging. So just very quickly brush up on that, just so you know that we're going to be using IDW. It's a very simple one. Kriging would be the next step of complexity. We're not going to be seeing that today, but I think you will be exposed to that in the future in this class. Okay, so I also want to come here and show you something else very quickly, which is just a comparison. So this again is not our data, but I just want to show you here. So where you see the crosses there, those are where the points for this field I think this is actually a state perhaps, I don't know. But anyways, the data points were collected where you see the crosses. And the key thing here is to show you that the first interpolated map we see is the IDW output. The next one is ordinary kriging, and then the third one is universal kriging. We have different types of kriging, as we quickly said, but the main point I want to make here is that these layers, these interpolation methods will give you different results. Which one is the best or most correct? It's up for discussion to some point. There are things we can do to assess how good they are. We're not going to cover those here today, but I just wanted to show you that just because, and this is important in precision ag as well, just because you're seeing an interpolated map, it does not mean it is a good map, because there are different ways of creating interpolation maps, and some are better than others, more suited to some situations. So as good agronomists say, it really depends on what you have there. The point here is that interpolated maps can be created differently depending on what technique you use.
We're going
Okay.
to spend a whole week on this with Professor Morari later in the semester, and he will follow up on what Dr. Basso said about how we measure the quality of our interpolation of discrete data points. Okay, so he'll teach you the methodology you use to decide which of the interpolation techniques better represent your data.
Perfect. That's awesome. Yeah, that's great, because we're not going to really cover that here. So yeah, it's just giving you a very quick overview of what will come up when that class comes. Yep. Okay, so what we want to do here, and a very key distinction, we interpolate mostly point data as we have here. So yield data is in itself a point data, right? Because you take a GPS coordinate at a point and you assign that to a yield measurement, and you take multiple points, even though it's very dense and it looks like it's continuous, but it's really not. If you were to zoom in enough, we would see the points being apart from each other. So when we interpolate, we have to create a grid of a given size, and we will tell pretty much the interpolation algorithm to predict what value that grid cell would have based on the underlying points that grid cell is covering. So because of that, we have to create a grid to begin with. So I want to ask you to come here to the next chunk. We're going to create a grid, and we're going to use the function st_make_grid. What I want to do is use our boundary as the outer boundary of our grid. So our boundary object is the boundary_w. You can add a comma and hit enter. And another thing that we have to provide here, there's an argument called cell size. So we need to say, what is the size of the cells of this grid that we're creating? I want it to be, in this example here, I wanted you to use the number 10, which our boundary is in UTM, meaning that its units are in meters. So this 10 here is 10 meters in this case. But something to be aware, if your layer was in WGS 84, this would actually not mean meters unless the function accommodates that, which some do, some don't. So again, the best way is if you're doing distance-based operations like making a grid, interpolating and all that, you really want to have your layer in meters or feet for that matter, but in this case, meters. Okay, so if you just run that, it should have created for you an object on your environment. If you print it, it says it's a geometry with one feature. And then if you just ask for the class, it is an SFC polygon. So it's still within that SF package family of objects at this point. So here comes the next step. So right now our grid is a vector file, meaning that each cell is like a little polygon. We're not seeing that yet. We're gonna have a map in a second here that you're gonna be able to see it. Oh, actually, that is this next chunk here is the map. So let's just make that map so we can really see this grid polygons on the map. So we can start with the EO clean map, which is the one that we created above. So we're just calling again. Basically, we're going to call this plot here again and just build on top of it because it is a ggplot. So we just say EO clean underscore map, add a plus, hit enter, and we're going to use geom underscore SF. Remember that SF is for these vector files, the shape files. So because our grid is a shape file, still is a vector file, that's what we're going to use, geom SF. So you say data equals grid underscore v. We can add a comma, hit enter, and I just want to change some things here to make it look like we can see what's behind it. So the first one is going to be alpha. Alpha in ggplot lingo means transparency. It goes from 0 to 1, so 0 to 100%. I want to set alpha to 0.5, meaning 50%. Add a comma, hit tab. I want to say fill equals NA. So it doesn't block what's behind it. Add a comma, hit tab, and say size equals 0.1. This is just going to decrease the size of the lines of the grid so we can, again, better see what's behind it. So if you have that ready, I'm going to run mine and I'll leave. Oh, something unexpected actually happened. Huh. Let me see what's going on. Maybe I got something wrong here without realizing. Let me look at my code. That's interesting.
It have to do with the fill equals NA?
So it could, but what's throwing me off is the fact that it's actually like changing the
shape, yeah.
Changing the shape. So that's kind of interesting because when I run just the map, it works. Huh. Yeah. Well, I'm gonna have to troubleshoot that. And oh, okay. I think I know why that was. Let's see. Oh, yeah. Okay. You know what? I know exactly what happened. Sorry. If you want to come back to the boundary, I forgot to actually type something here for us. So when we bring in the boundary, we see it's in WGS 84. So we have to change the boundary, which affects the grid because the grid is based on the boundary. So we did not have to do that for the yield one, but we do have to do for the boundary. So if you just want to come back to the boundary chunk, hit tab, then we're going to use that function st transform. And then it has an argument called CRS. And the one that we want to use for UTM zone 16 north is number 6345. Yeah. So yeah, I think that's where the error is. So if you just want to do that, you will have to rerun that. So don't forget to rerun that boundary chunk and double check that it is saying projected on that first pane that appears. Yeah, and then you
Code
will
again
have,
for the transformation 6345.
yes, 6345. Mhm.
That fixed mine.
Sorry, what was that?
I just said it fixed it.
It fixed it?
Mhm.
Okay, perfect. Yeah, so you will then rerun this boundary chunk. You will have to rerun as well the grid one, because remember the grid is based on the boundary. So if we rerun that, and then you go back to that plot that we were making, now it should look as I was expecting to look. Yeah. So you should see something like this, where you see that what basically did, so because we gave the grid function, we gave the boundary as the template, it basically looked for minimum and maximum y values, minimum and maximum x values, and used that as the bounding box for the grid. So that's why we see that the grid cells, they do overlay our map, but they're also outside the map where we don't really need them to be. Anyways, this is how the grid looks like, and this is what we're going to interpolate to or into. We haven't done interpolation yet. This is just to show the grid that will be used for that. Okay, so we are at 10:11. I'm not going to be able to finish today for sure. So what I want to do is we're going to stop here. I was planning to go a little bit later, but I know that Victoria and Spen have an exam following, so I don't want them to. I want to give them some time to catch up. I always did when I was taking exams, so I imagine maybe they would like to use that time too. So let's stop here. We'll probably continue this. So this next week, Lorena, you're going to be watching the class with Lorena. And then perhaps the following week, I have to just double check later with George to see how it fits best. But we will continue this at some point. Okay?
Yeah, we can continue this a week from Monday.
Perfect.
Yeah.
Yeah, and I have to see, because I have a conference at some point. I just have to see how that matches, but we'll
We'll fit the schedule in. Don't worry about that. We'll continue with this because this is interesting and a valuable tool for everyone.
Absolutely. So we will continue with this in the future. Still, if you have any issues, any questions about what we covered, or if you're going through something and you have a question, feel free to shoot me an email or stop by my office. And I just also wanted to say that, yeah, I guess we can stop here. I'll have more things to say, but I can send them by email to you guys. Do you guys here in the room have any questions? Okay, we're good here. In Zoom, anyone has any questions? Okay, I don't think so. So yeah, I guess we can wrap that up. Thanks everybody, and I'll see you in a week or so. We'll continue
Okay.
this.
And everyone remember that beginning Monday, everyone has to be in the labs, and otherwise you will not be able to follow along. Okay. Okay. Bye.
Awesome. Thanks.
Thank you.